So in this little segment, we're going to focus on basics of the SQL language and how to work with databases in general. So this is where we get to the definition of the data storage systems, basics of the database environment, and some DML statements. The acronym DML refers to data manipulation language. So let's get started. So what is a data storage system? A system in which you can add, delete, update, or retrieve data. So data is basically a set of records, and after you end up analyzing data, you end up with information. So information is what is the difference between data and information? Data refers to a set of records, and information is meaningful inferences from data. So what would be a good example of that? So we all go shopping to grocery stores. What everyone buys is data. So at the cash registers, whatever, a lot of data is collected regarding whatever people are shopping for. And information is what brand of milk was most sold in a given day or in a given time frame. That becomes information. And information becomes useful for a specific business case. It necessarily does not have to be a business case, but since we are talking about the business world, we can think of the business case. So guys, obviously getting the latest edition of the text is fine. Let's stay focused on the topic we are on. And questions like which book, etc., you can most likely also email me and I'll gladly answer those one-on-one. So a storage system is where you end up adding information, adding data, deleting data, updating or retrieving. And then once that is stored somewhere, we can use third generation or fourth generation languages to write programs to access that information. There are also a lot of development tools, including a lot of the web applications that are created are used for accessing that data in a meaningful way. Data by itself has no value, but information is of specific value to the person using it. And using the example that I provided, you can probably use that as an inference as a starting point for coming up with other examples. So there are lots of different type of storage structures. We've got flat files from the old record systems, and we also have these modern database systems, hierarchical, network, relational, and also object-oriented. And today we have NoSQL systems and also big data systems like Hadoop, which is one of the more popular ones. So (3GL) and 4GL are different type of, these are different generation of languages, programming languages, that can be used for writing programs. So third generation programming language would be something like C, or fourth generation would be like SQL or Java, that is used for writing programs to retrieve data from the database for meaningful purposes. So if you're using simple text files or spreadsheets, those are all referred to as flat file systems. And there is in fact an issue with flat file systems that I'll explore in a moment. And when we have a set of these files that are saved in one directory, and these files really don't have any links, but we write programs to connect these files. That was the architecture of hierarchical / network database systems. Realizing the limitations of hierarchical and network systems and flat files, the concept of relational modeling was coined by Oracle. Oracle was one of the first relational database systems that was released. And after that came object-oriented, which basically uses the notion of objects for persisting data in the database system. So what's wrong with flat files? So let's say in a network or a hierarchical system, you have these three files: customer, order, and product file. So in the customer file, we save name and address and a customer ID. In the order file, we save customer number, order number, product ID, and quantity. So basically, how much specific quantity of a product a particular customer is ordering. And we also have product file, where there is a product ID, name, price, and description of a product. And say we have these three separate files, and there are three separate programs that are working together. Program 1 removes a customer. Program 2 is entering a new order for a customer. And Program 3 is also removing a product. And it turns out an order is being placed for a customer that is being removed using a product that is also being removed. You guys understand how we will get data inconsistency in this situation? If the customer is removed and the product is removed and all we are keeping is the customer ID and product ID in the order file, the references for the customer Smith and product P1 are going to be gone. So we'll be placing hoax orders for customers that do not exist or product that doesn't exist. So that is because there is no linkage between these files. It becomes a high risk for data inconsistency. Also, if the structure of the data file changes, meaning we end up adding another property in the product file, like manufacturer, and if the program does not change, then that can also cause issues. So working with flat files is a significant risk in its own way. So if you try and make the files independent, you'll be duplicating a lot of the data. So let's say if I make an order file that has all the customer information and all the product information in it, I will be duplicating customer information every time, thereby using extra storage space. And that is the reason to create a customer file so I can remember the customer Smith once and use that information in order file and product file by making these cross linkages supposedly. So if you understand the issues that are being reflected on with working with the flat files, then the solution to solve those issues are done with the relational database system. So what we do is we, in a database, have a set of users, and we also end up creating three separate tables. We've got the customer table, the order table, and the product table. Customer table has customer ID with name and address, and the information is really not duplicated. We have the order table that has order ID, and we use customer ID as a reference to link to the customer table. We also use product ID to link to the product table. And then we have quantity and order ID, which is additional data to indicate for a given order and a given customer what product was ordered and the quantity there. So obviously these three tables are linked, and then there is a structure that is created inside the database in the file system to store that data. There are links, logical links between different tables, but there is no linkage with the files. And by doing that, we are able to come up with smarter, better information. There are no programs to write other than using SQL to gain access to the information that can be extracted using the structured query language, which is what you're going to be learning in this course. So just to cover a couple of database concepts that are going to be useful in your first assignment. So if I look at the customer table, customer ID is a property, and it will always have a unique value, always. So when we create a situation like this, we are basically creating a primary key. And customer ID is a property of customer table. If we look at customer ID in order table, it is referred to as a foreign key because it refers to customer in customer table. It refers to customer ID in customer table. So by using a primary key and foreign key, I've made a link between two tables. When we talk about linkages between different tables, this is how we create. Now, how are these links used when data is added in tables? That's another very basic question that one has to know or one has to address. So for that, I'm just going to start Excel and just show you a couple of things here. So I have my customer table and I have customer ID, and what were the other two properties? Name and address. So let's say customer ID is 1, customer name is Bob Singh, and address is and then we have the order table, which has customer ID, order ID, product ID, and quantity. Is that readable, guys? Okay, so customer ID is 1, order ID, it's my first order, product ID is also 1, and quantity is 10. So let's say I also have the product table, and the product table has product ID, name, and price. So product ID 1 is Big Mac and price is $9.95. So I want you guys to focus on the links that are being made here data-wise. Customer ID 1 is linked to customer ID 1 here. So 1 here means Bob Singh at this address. Order ID is just a unique value created as a primary key in the order table. And if I'm ordering product ID 1, that is linked to this specific product. So I'm hopefully helping you understand how these linkages are made with using these different colors. So let me go ahead and maybe add some, like 1 or 2 more records just for illustration purposes. So let's say we have another customer my neighbor, let's say, and we have other products. Sorry, forgive me, I couldn't think of better products than these for today at least. So customer ID 2 is creating a new order. And she wants to order these products all in the same order. And hopefully you'll begin to see some of the variations here. So we have customer ID 2 and she has ordered product wrong color. She has ordered this product and also product 2 and 3. So just for illustration purposes, we will try and use a couple of different colors for making the point clear. And product 3 is here. So all on one order, guys, we have these 3 products, 1, 2, and 3, and I've got 3 items on the same order. That's why I've repeated this 3 times. Order ID will be unique, but when I have one order with multiple items, it will be duplicated. But what we can do is we can make sure that combination of these three columns are basically the primary key for the order table. We'll talk more about primary keys in depth down the road. But what I'm trying to illustrate in this with this data to everyone is how we can save information separately for product and customer, and then create a link of customer, order, and product in the order table by using customer ID and product IDs as foreign key. Okay? Does anybody have any questions on how these linkages are created and the value proposition? So, few things that you might consider noting down here, right? If I delete, so with the current situation that you see in the spreadsheet, if I delete order ID 1, customer ID 1 and product ID 1 are still intact. If I delete order ID 1 in order table, so as long as there are orders for product ID 1 or 2, those products cannot be deleted from product table. And we can also say the same thing for customers. Like, as long as there are orders for a given customer ID, those customers cannot be deleted from customer table. So this is a concept of referential integrity. And you essentially really just need to remember this when working with relational systems. If a product that is no longer offered, if you end up in those situations, then you basically have a column like offered or not. So you don't really delete anything from databases. What you say is, okay, we sell Big Mac and nuggets, but we don't sell cheeseburgers. So anything with the value of 1 is offered. Anything with the value of 0 is no longer offered. So it's very much like your Facebook accounts. Those are never deleted, really. It's disabled. And you can go back and enable it at any time. So please focus on the concept of referential integrity And take notes to this because it will be useful in your first assignment and also for exams. And it's the very basis of relational modeling. So after having talked to you guys about the basics of tables, columns, and links between different tables, I want to take you guys through the basics of a database environment. We already saw that creating physical files is not useful. But the irony of working with operating systems is that everything is stored in a file at the end of the day, even a database. But these physical files are created by the operating system and given to the database for managing the structure. And there are no linkages between these physical files. And then there is something called an instance. An instance is a program that consists of memory and a set of processes. And the instance is accountable for all of this: selecting, updating, deleting, inserting data. The memory every database system has, the memory is called the System Global Area in Oracle. This is a term that they use for defining the memory. And whenever you hear the term instance, it's referring to process and memory together to manage the physical set of files in which the data is contained. To go back regarding talking about the foreign keys, as long as there is a foreign key and there is a record associated with that in the table that has the foreign key, no data is deleted. That is accurate. And value being set to 0 is in a non-key column. It's not a primary key or a foreign key, it's just a property that is set that you can use to, you can set up a business rule to say 1 means products are offered, 0 means those products are no longer offered. So talking a little bit about how tables come together in the database. So you create a table like we talked about. Those tables are stored in a database on physical files. And whenever a user wants to access that data, user will make a query. That query is processed, and the results are thrown into memory and presented to the user in form of a well-formatted report. So when you start working with relational databases, you end up managing both the physical structures as well as the logical structures. In this course, you're going to learn about both: how to manage the physical structures and also the logical structures. Since we have to create a database to do queries, we're going to focus on learning the logical structure before we step into learning the physical structure. So most of your time will be spent in the first half of the course learning about logical structure and querying data. And then finally you'll get into working with the physical structures later on. So columns, rows, and keys. So let's say we have an employee table and a department table, and these are the columns that each of those tables have. Employee table has a primary key. Primary key means this column employee ID will always have unique employee numbers. When department ID is a primary key, it means all the values in the department column will also be unique. You can also see each table is like a separate or an independent spreadsheet. Like department table has 3 attributes, so therefore 3 columns. And the data that is associated with department table is stored in a row, and we have 4 departments, therefore 4 rows. Now we want to create a link between department and employee. So we take department ID and make that a foreign key in the employee table. So when this primary key, foreign key relationship is set up as you see in this picture, we enable a referential integrity. So let me repeat this in context of this another example. I guess the repetition is good because this concept really needs to be understood. So for referential integrity here, we can confidently say that department ID cannot be deleted from department table if it has employees. Another thing, no employees can exist for department table 50 because 50 is not a valid department name. It's not a valid department number. So Stacy, the department ID can be deleted from department table if it has no employees. So right now you can see 10, 20, 30, and 40 all have employees because we have these cross references, as you can see. So none of these departments can be deleted as a result. But let's say I get rid of employee ID 500, which is in department 10. If I delete that row in this picture, then I can get rid of this row, the accounting row in the department table. Okay? If there was a reorg, then you would be required to move all the employees to different departments before you were to delete that department ID. Okay, very good. So please understand, guys, columns, rows, and keys. We talked about some nice example here with some colors. And there is also a formal representation of rows, columns, and linkages between those two tables in the picture that you see. If you, of course, have any questions, those are welcome. Each table will have its own primary key. That is correct. Each table will have its own primary key. And a primary key can have one or more columns. It's, as we start off, we start creating primary keys that have one column, but in the future, you will certainly end up with tables that have columns, more than one column for the primary key. Then we have a concept of an index. So index is very much like the index that you have in the back of your book. It's a sorted structure that has a list of topics and then page numbers. So whenever you have a question about a topic, you go in the index, you look up the topic name, and you find one or more page numbers to go to find that information. That has long been the standing way of setting up indexes. In a typical database, what happens is you have a set of rows, and each row has a unique ID that is internally known to the database as row ID. That is similar to referring to a page number for a topic in a book. Then when we create an index on a table in a database, we decide which column we are going to index. And that decision is typically hinged on which column is used most frequently for retrieving data from the database. And in this case, in the picture, we use employee ID. And when the index is built on the employee table using employee ID, we basically have employee ID and row ID. Basically, the row ID, it's pointing to the record in the table. So now, if I were to run a query, and I were looking for employee ID 200, let's say, I can go directly to row A1 and fetch all of that information that corresponds to employee ID 200. So yes, going back to the question of deleting a department that has employees, you have to delete all the employees in that department before deleting the department. That is correct. So this is how an index is created and used. We also have procedures. So there are part of SQL is procedural SQL, where we write functions and methods, and those procedures can live inside the database. It contains the syntax to fetch data and perhaps maybe service a report or do some other things. So how do you communicate with the database? There is usually a client program where SQL statements are created and entered. That information is sent to the database. It executes and returns the results back to the client. And this communication happens over the network. So bringing you guys back to some of the basic lexicon that is associated with database and storage. We have spreadsheet, filing cabinets, and databases. These are all metaphorically similar in some way, as we have mentioned. The relational database theory that we're going to be talking about in good depth in this course was proposed by Dr. Cord in 1970, which is the basis for creating relational databases or creating relational database management systems. According to Dr. Cord, a relational database system is a collection of objects or relations. This is referring to tables that we just spoke of. Then there are a set of operations that can act on those tables. So we build relationship between different tables. And when we talked about the concept of referential integrity, it essentially infers data integrity for accuracy and consistency. So when primary key, foreign keys are set up on key columns, it becomes hard to delete the row should there be corresponding links associated with that row. So relational database consists of two-dimensional tables. We talk about columns, column names as one dimension, and column rows or rows in the table as the second dimension. Employee and department tables are going to be very common for this particular course because we are using those two tables in a lot of the queries. When we have an idea for creating a data store, we have to create a data model. So data model is a set of tables. So it's basically a picture that shows a set of tables and how those tables are linked with each other. And we use, you'll end up drawing one of these diagrams in this course for one of the assignments I'm going to have you do in the near future. Then from each entity that is defined in that model, we end up creating tables. So entity and table are synonymous. And then from the table, we end up creating the tables for using in the database. So we are really talking about entity model and table model. How are the two different? Entity model is a business representation of data. Table model is how it will be implemented in a database. So if you look at entity relationship model, this is how it's set up. We have an employee table, a department table. There's a primary key. So this notation is explained in one article that I've posted along with today's assignment. So hash means that it's going to be a unique or a primary key. Star means it's required. It cannot be null. O means that it can be optional or not null. So for a given employee, I must have their employee number and name. But if I don't know their job title, that's probably okay. And same thing for department. I must know their number and name. But if I do not know their location, that is most likely okay. So there are these conventions. O means optional, asterisk means marked, and hash means it's a primary key. If a column defined here is a foreign key, then that should be remembered with, or that should be marked with these circular brackets. Tables can have relationships like a dashed line, solid line, crow's foot, or single line. And each one means different things. For today, I just want you guys to know this at a high level, but when we get to lab 6, you'll actually end up implementing this. So if I have a solid line like this, what this is saying is that department must have an employee, and it can have one or more employees because this little crow foot means many. And it's saying employee must belong to a department. So using just this middle part where we are referring to the relationship that is set up between the two tables. So linking tables with department ID and with department ID in the employee and department table. So these are some more notes on primary keys and foreign keys that you should get to learn. We talk about single row, column lists, column containing a foreign key, a field that can have null values. So these slides are in a way also your notes, and it describes all the basic concepts in good detail. So please do consider referring to this and learning from it. Then we have a set of DML operations. You're not going to require these for your first assignment. So I'll go ahead and stop here as far as the first topic goes. And what I'd like to do is talk about what the first assignment is and how to go about it, and also show you how to go about logging into Oracle, because I think that is one of the key things that you're going to be asking a lot about. So in assignment 1, I have these 5 questions for you to answer. Does the crowfoot mean must have at least 1, or it can have more than 1? It is 1 to many. If I wanted that to be like 0 to many, then I would draw a crow's foot with a 0. I hope, Stacy, that helps. So here are the 5 questions that you have to answer. What's an entity? How is it defined in the database? And what does a row and a column represent in a database? What is a primary key and foreign key? And explain the implications of using these keys in different tables. Then talk about referential integrity and 4 advantages of it. What is a data dictionary and how is it used? So data dictionary is a set of database tables that contain information about all the database objects. So anytime I want to retrieve a row from the table, I would use data dictionary. So it's used all the time for finding system information on the database. And then the last one that I'm going to leave you to attempt on your own is the 3 rules of normalization and how is it applied to the database schema. Now, of course, I know I didn't cover this in detail. Maybe I did, but you should please read this document that talks about the first, second, and third normal form on pages 3 and 4. So look through this article to answer this question. Okay? So this should get you started.